In this video, I want to have a look at parametric equations of parabolas. So in mathematics, when we were looking at locus, we looked at the four standard forms of the parabolas. So we had concave up, down, left, and right, and the equations that represent each of those. So the standard parabolas, again, are the ones that have their vertex at the origin. So this time we want to have a look at parametric representations of those four standard parabolas. So if we have a look first at the one we're most familiar with, at a concave up parabola, we know that it has equation x squared equals 4ay in Cartesian form, but we can also represent it with parametric equations, x equals 2at, y equals at squared, and t is just our parameter. Again, a is our focal length of our parabola. So that means that this is the x and y coordinates. So the point 2at, at squared is a point that lies on that parabola. Now we can prove, before we prove it, this is on your formula sheet. So it tells you that this parabola is represented by these parametric equations. It doesn't have the other ones, but you can work them out from here. So we can prove that this is the parametric representation of this by rearranging these. So if we take x equals 2at, we'll call that equation 1. We'll call y equals at squared equation 2. So from equation 1, if we rearrange that, we could have t equals x over 2a. If we sub that into 2, we'd have y equals a outside of x over 2a all squared, which is equal to a times x squared over 4a squared, because when we're squaring it, we're going to square everything that's in there. Now that a will cancel out with one of the a's down here, and we'll just have x squared on 4a, that's still equal to y. If we rearrange that, we'd have 4ay equals x squared, which is our Cartesian form. So to summarize that, our x squared equals 4ay in a Cartesian form can be represented by x equals 2at, y equals at squared in parametric form, and that's our concave up parabola. We can also look at it for our concave down and our concave right and our concave left as well. So if we look at each of those, we know that a concave down parabola has form x squared equals minus 4ay. Parametric equations would be the same here, but our y is going to be negative. For our concave right, we've got y squared equals 4ax. So then our x and our y have just switched around here. So our x is at squared and our y is 2at. And for our concave left, we've got that minus 4ax. So our negative has come back in front of that at squared. So they are the parametric equations for our four standard parabolas. All right, so let's have a look at a few examples. So our first one says, given the parabola x equals 4t, y equals 2t squared, find its Cartesian equation, and the points on the parabola when t equals plus and minus 2. So for the first part, to find its Cartesian equation, we're going to call this equation 1 and this equation 2, and we're going to rearrange them to eliminate t. So from 1, this is part A. From 1, we could rewrite it as t equals x on 4. And then if we sub that into 2, everything's lagging, hang on. So sub that into 2, we'd have y equals 2 outside of x on 4 squared. Now if we keep going with this, we'd have 2 times x squared on 16. If we simplify our 2 and our 16, divide them both by 2, and we'd end up with an 8 in the denominator. So we'd have y equals x squared on 8, or we could write that as x squared equals 8y. So this is the standard form that we're more familiar with. For part B, we want to find the points on the parabola when t equals plus or minus 2. So let's have a look at t equals positive 2 first. Then we can substitute this into our x and our y. So we'd have x equals 4 times 2, which is 8. And we'd have y equals 2 times 2 squared, which would be 2 times 4, which would be 8 as well. So at t equals 2, the point is 8, 8. Then we can look at t equals minus 2. So we'll substitute that in as well. So we're going to have 4 times minus 2 for x, which will give us minus 8. And for y, we're going to have 2 times minus 2 squared. Now minus 2 squared still gives us a positive 4, so 4 times 2 will give us 8. So then our point is minus 8, 8. For our second example, we're asked to find the coordinates of the focus and the equation of the directrix for the parabola x equals 12t, y equals minus 6t squared. So there's two methods you could use to solve this problem. One is you could rewrite these and translate it into a Cartesian equation. And then once it's in that standard Cartesian form, you can find the focal length, and then you can draw a sketch and you can find out your focus and your directrix. The more direct way to do things, though, is to recognize the general parametric form that this is in. So if we have a look at those and compare them to the 4 different forms, standard forms of a parabola, we can recognize that this is in the form x equals 2at, y equals minus at squared. So that's going to be a concave down parabola with a vertex at the origin. We can also then compare these to this, and we can see that our a is going to have to be equal to 6. So our a there and our 6 here. And we can see that that works in our first equation as well, because 2 times 6 does give us that 12. So then we know that we've got, if we draw a sketch roughly, we've got a concave down parabola with its vertex at the origin. We know that our focal length is 6, so our focus is going to be here, which would be at minus 6. So our focus is going to have coordinates 0, minus 6. And the directrix has to go along here. Again, the focal length here has to be 6. So our directrix will have equation y equals 6. For our third example, it's given us the equation of a parabola in Cartesian form, and it wants us to write it in parametric form instead. So to do that, we're going to recognize that this is in the form x squared equals 4ay, and we can use that to help us find what a is. So if 4a is equal to 32, because that's the coefficient of y, then a is going to be equal to 8. Now from there, we can also recognize that because this is a concave up parabola, it's going to satisfy the parametric equations of the form x equals 2at, y equals at squared. And now we know what a is. Our equations are going to be x equals 2a will be 2 times 8, which would be 16t. And y is going to equal 8t squared. So this is the parametric equations that represent this parabola. Our last example is fairly similar, except this time we've got y squared equals 12x. So that means it's concave right parabola. So we know that it's in the form at the moment y squared equals 4ax, which means that our 4a is equal to 12, so a is equal to 3. And we also know that it's when we translate it into parametric form, it's going to be in the form x equals at squared and y equals 2at. So that means for us, we're going to have x equals 3t squared, and y is equal to 2 times 3, so 6t. All right, so that's our solution there. That's rewriting that Cartesian equation into parametric form instead. So that's having a look at the parametric equation of standard parabolas.